Hey guys, so we're going to go on to lesson 3 after we had our practice day. Just a reminder, if you have any questions about these lessons, please just send me a message or a remind or something. Get in touch with me and we'll meet up and we'll fix those issues. So today we're going to talk about something very similar. We're going to say how can we determine relative and absolute extrema on a closed interval. So no longer will the graph go infinitely right or left, it's going to be a closed interval. Now what that does is it's going to create these absolute max and mins instead of just relative max and mins. So it says, use the diagram below, answer the following questions. So first it says, identify which points would be classified as, first, a relative extrema. Relative extrema really are any highest or low points. It's anywhere where the slope changes from positive to negative. So we see some extrema here, right? Down, 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 then it switches to up. So A is an extrema, B is an extrema, C is an extrema, D, E, nope, sorry, I lied. C is not, right? C is still going down, it's just a 0. D, positive, 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 switch to negative, so F, and then negative switch to positive, so G, right? Which one of those are minimums? A, D, and G. Which one are maximums? Maximums, B, and F, okay? And that makes sense because there are 5 total, 3 are minimums, 2 are maximums. Now, absolute minimums. Is there at a very, very lowest point? Yes. What is the absolute minimum? D. Even though A is a minimum and G is a minimum, D is the absolute minimum. What about the absolute max? Well, it goes up forever, so we actually don't have one. It does not exist. However, the question down here states, if the arrows were changed to endpoints, so forget arrows, let's make it a point. Now does this have a highest point? Yeah, A, B, C, D, F, G, let's call this H, let's call this J, I don't want to use I. So now, I don't know if they're probably the same height, so let's say H and J are now absolute maximums. So what happens when we have a closed interval? Sometimes where you don't have absolute maximums or absolute minimums because it goes up or down forever, now closed intervals creates those absolute, the very highest or very lowest point. Okay? So what do we do how do we solve this then if we are given a problem? How can we tell if something is the absolute max or absolute min? And we'll get there in a second, but let's just look at one more example here now. So first off, what are all the relative extrema? Where does it change from positive to negative or negative to positive? Maisie does not like this. She is staring at me. So let's see. A is the lowest point. B is a turning point. C and D is the highest point too. Minimums, we got C, we got A. Now it's interesting, is A a relative extrema? Is D a relative extrema? Well, is it a turning point where it goes from positive to negative? Not really, so should we be including it there? I'm going to say no. Okay, so I'm going to say the only relative where we change from positive to negative, relative min, is going to be point C. And the relative max, point B. Now the absolute minimum, what's the lowest point on the graph? That's point A. And what's the highest point though? That's point D. So let's take a look here. Given the function, determine the absolute minimum value of f on the closed interval from -4 to 2. So a couple of things. First, we could find those relative extrema by using the first derivative test and telling where the slope changes from positive to negative, right? Or negative to positive. So first, let's take the derivative here. So f prime of x is -3x squared minus 6x. Okay, so now let's set this equal to 0. And let's solve when this equals 0. So we get -3x GCF. Let's see if that's right. -3x squared minus 6x. That's good. So we get when x equals 0 and when x equals -2. So now we have to do our first derivative test. and we're going to check the regions. Oh, sorry. -2 is less than 0. And we're going to check, remember, how many spots are we going to check here? We're going to check 1, 2, 3. So let's substitute in 3 different values. 1 to the left of -2, 1 in between -2 and 0, and 1 to the right of 0. So we have to find what's f prime of, let's do -3 first. And remember, just a hint, use the factored form because you only care if it's positive or negative. You don't really care what the number is. So I'm going to write -3 times -3, and that times -3 plus 2. So -3 times -3 is positive. -3 plus 2 is negative, which means a positive times a negative, negative. Now let's check something between -2 and 0. Let's find f prime of -1. So you get -3 times -1, which is positive, and you get -1 plus 2, which is positive, which means positive times a positive, positive. So at first the graph slopes are going down, then they're going up. At -2, we have a minimum. Okay? Now, let's check a point to the right of 0. What's a point to the right of 0? Let's pick 1. What's f prime of 1? What's the slope of the tangent line at 1? Is it positive or is it negative? So we get -3 times 1, which is negative, and then we get 1 plus 2, which is positive, and a negative times a positive, negative. So it goes back down, so that means if it goes from positive slopes of the tangent line to negative, this is going to be a maximum. Now, how do we know if this is the very lowest or this is the very highest point? Well, we plug in and we'll see. Let's first get what these points are. I'm going a little quickly here. Let's figure out what these points are. So I'm going to shrink this down a little bit. And remember, I'm going to go back in now. I'm going to find what is in my original function, f of -2. Plug it in. So we get negative parentheses -2 cubed minus 3 times -2 squared minus 2. So that's -2 times -2 is 4 times -2 is -8. -8 is 8. -2 squared is positive 4. 4 times -3 minus 12 minus 2. So that's 8 minus 12 is -4. Minus 2 is -6. So there is a minimum at -2, -6. Now let's find out this maximum here. So let's find f of 0. So when you plug 0 in, let's see, we get -0 cubed minus 3 times 0 squared minus 2, which is very easy because that's 0 minus 2, it's -2. So there's a maximum at 0, -2. So right now, the lowest point we know is -6. The highest point we know is -2. But there could be higher or lower points, believe it or not, because what about the endpoints themselves? And I'm going to go back to this example up here. Take a look. Yeah, this was a relative max and a relative min, but notice that D and A were higher and lower. So we have to check the endpoints to see what's happening there. So to do that, next up, we just have to find 2 more points. We have to take our interval and substitute in -4 to the function and 2 to the function to find out what the endpoints are. So once again, let me just shrink some of this down and get us some more room here. So let's find f of -4. And it's going to be a little bit of work. That's okay. So you get -4 cubed minus 3 times -4 squared minus 2. Now keep in mind, if you put everything in parentheses that you're substituting in, you could just do this right in the calculator, and scientific calculator save us some time. Let's see. Negative parentheses -4 cubed minus 3 times -4 minus 2. And you get 74, which is pretty big. Yeah, that makes sense. So you get f of negative 4 is 74. So that means that, well, the point negative 4, 74 is part of our graph, right? So is that higher than the maximum we found earlier? Yeah. 0, negative 2, and negative 4, 74. This is much higher. So this is going to be our absolute max. All right, let's plug in our other endpoint here. Let's plug in 2 in the closed domain. What's f of 2? Well, that's negative of 2 cubed minus 3 times 2 squared minus 2. You can do it with or without a calculator. That's negative 8 minus 12 minus 2, which is negative 22. So that means the point 2, negative 22, is that lower than the relative min we found earlier? Negative 2, negative 6. Y was negative 6. Now y is negative 22. So this is the absolute minimum. So now, again, let me just reiterate what we're doing here. We're finding these relative mins and maxes using the first derivative test, but then we're seeing, are there any points on this closed domain that might be even lower than this minimum at negative 2 and even higher than this maximum at 0? Plug in the endpoints and find out yes or no. Okay, let's look at this graph. You could always look at the graph after and kind of see what's going on. So I'm going to graph this. Negative x cubed minus 3x squared minus 2. All right? And remember, we're only looking between negative 4. I think I could even do this. Negative 4 less than or equal to x less than or equal to 2. Enter. And if I zoom out, there it is. And we can kind of see, what is the relative min? We found this one. This relative min at negative 2, relative max at 0. But look, between those values, that's the very, very lowest point. What is that point? 2, negative 22. We found that already. What about this point? Well, that point's the very highest point. It's the absolute max. What's this point? Negative 4, 74. Oh, obviously not. I must have made a mistake plugging in. That's not 74. Looks like 14. Where did I make a mistake? We should fix that, though. Pretty sure that point is 14. Let's do a table of values. For negative 4. Yep, 14. Oh, sorry. Let's fix that. But we get the main idea. Okay? So it's 14. There you go. Okay, so what I'd like you guys to do is try 2 and 3, and I'll post the key eventually, and you guys can check it. Again, do the first derivative test to find the relative mins and maxes, and then go back in and plug in the endpoints to see if they might be higher or lower, and there you go.